in the video today, the notes will be a little bit of a challenge, I perceive. Basically what you want to do is allow yourself the ability to be able to kind of pause and be able to write things down. So hopefully you're next to a computer or someplace close to where you can pause this and start it whenever need be. Because what I'm about to talk to you about is inverse involving trig functions. Now you have to understand basically what an inverse function is. An inverse function is really a way of looking at a function in the opposite direction. When I think of inverses, it's like I'm giving you the answer and you coming up with the question. It's really a game of Jeopardy. And so it affects even the graphs. So again, it would be if I was asking you, okay, the sine of pi over 2, you understand to be 1. It would be like me saying, okay, when does sine equal 1? And you asking that question. So in other words, I'm giving you the y value first and then asking you to come up with that. So I want you to think about that. So if in this case we look at, okay, the sine of pi over 2 equals 1. And so when would sine equal 1? You would say, of course, x would then be pi over 2. Well, basically what's happening is I'm giving you the y value and I'm asking you to generate what would that value be? When would that occur? And that's in essence what's going on in an inverse sine type of a situation. So when we're looking at the graph, what basically happens is your coordinates flip around. Instead of it being xy, it literally becomes yx. So I want you to see how that would look on our graph. Instead of being pi over 2, 1, it would become 1 pi over 2. Let me just see what I've got down here. Okay. So what I've got here is I want to basically look at the graph and say, okay, so let's call this 1. And so I have 1 pi over 2 would be where we would start. At 1, we'd come over on 1 on the x, and it would go up to pi over 2. And so that's where we would be. If I was to look at pi, well, pi is 0, right? So then that would mean at 0, we're going to be pi. So I would go to 0, and I would go up to pi, and so that would be here. By the way, I didn't answer this one, but 0 would be 0 whether you flipped it around or not. And then this would be 3 pi over 2. And that is, of course, -1. So it would become -1, 3 pi over 2. So -1 would be over here, -1. 3 pi over 2 would be up to here, right? And so let's say it's -3, -1, 3 pi over 2, mapping that coordinate. So if you could start to see what's happening here, and so 2 pi is 0, so back to 0, 2 pi would be another point. This can go in the similar direction. Can you follow what would happen below the graph? So if we went to negative pi and negative pi over 2, it would follow that same pattern all the way up and down. Now what's the problem with this? We haven't discussed too much about functions yet, but do you understand that a function has to, with every x, only go to one y? And so the way we look at this is we talk about the vertical line test. And if I was to draw vertical lines, you would see, oh my goodness, it fails, it fails, it fails, all the way up and down this trig function, this inverse sine function. It isn't a function in and of itself. So what happens to us is what we basically look at is we've got this, and I just want to do a better drawing here. So we have this inverse sine graph that kind of goes up and down this whole thing. And what we basically want to do is make it so that it's a function. We want to restrict it so that it actually falls into a function. So here's how we do this. I want you to start by looking at this lovely graph. We're going to start at 0 because that's always where you're going to start. 0, 0, that's how, and we're going to go in the positive direction because that's how we move. We prefer the positive until we fail the vertical line test. And at that point, we're going to stop. So if you can see me drawing here, I'm going to stop right here because if I was to go any further, it would, again, fail that vertical line test. So we're going to cap this off right there. And that only, though, if you understand the graphs here, that's only covering our positive answers. But we understand that there are times where sine is negative. And so we find that by going in the backwards direction here. Oh, and there we have to stop again. Now this section that you see I've highlighted is what we call the principal branch. You actually would see this on a reference sheet and indicated as saying you can only use values between, now that's the next part of this. What is this value here? What is, we know the x value is 1, and we understand -1, but when we're talking about inverses, we're going to actually limit it by the range here, by that y value. And so what is that? That is pi over 2, and this is -pi over 2. So sine, rather the inverse sine, is restricted between -pi over 2 and pi over 2. Okay? Now, that's sine. Now I want you to think about what that means. That really is looking at, if you were to think of your coordinates here, all students take calculus, it's looking at the first and the fourth quadrant, but it's looking at it in a way that, okay, we have the first quadrant answers, and then we just negate them for the negative answers. It's really that simple. So if I wanted to do a sine, and I wanted to figure out, okay, when does sine equal 1/2, you would quickly say, of course, pi over 6. If I wanted to know when does sine equal -1/2, I would simply say -pi over 6. And that would basically fall within that. That's all that that means. So if you hear a question that says principal branch, find this answer with using the principal branch or whatever, that's basically saying either the first quadrant or the fourth quadrant when we're talking about sine. Now this changes, of course, as we start to think about cosine, because cosine is positive in both the first and the fourth quadrant. So now we're looking at this cosine curve, and I want you to think about this inverse graph. This inverse graph, similar to the sine graph, we basically are going to switch the points around. So at 0, currently, it's 0, 1. So what we're going to do now is it's going to become 1, 0. And then this is the point pi over 2, 0. And so what we're going to do is 0 pi over 2. And then instead of being pi -1, it's going to be -1 pi. And honestly, once you get that thing into motion and start to see what it's doing, you can pretty easily draw that cosine curve. So as you think through this, your inverse cosine curve starts at 1 and then does that cosine curve up and down throughout. But again, it fails the vertical line test quite quickly. And so we have to restrict its domain as well. So we're going to start at the 0 spot, and we're going to look, okay, this is where it starts on that axis, and that's where we're going to begin. And we're going to move in the positive direction until it fails a vertical line test. Still doing fine, still doing fine. And as I move into the negatives, oh, we're still fine. And then we have to stop because then it would overlap with what you might see here. So we're going to stop right there, and that would be where we would stop it. This is what we call the principal branch for cosine. It looks simply like this. And that's the principal branch. Now, where is it confined to? Well, you'll notice it starts at 0, right? It starts right there at that 0 spot, and it's going to go all the way to where is this first dip of -1? To pi. It is. And so our principal branch is limited between 0 and pi. What does that mean in terms of your quadrants? If we were to look at, oh, students take calculus in this realm, we see that cosine is positive in this first quadrant, but it's negative in the second. We couldn't use the first and the fourth because it's positive in both of those. So it can't work there. We have to use the first and second quadrant. So for cosine, you're going to use the first and second quadrant angles. So now let's do some examples of how these get applied, and then tomorrow in class we're going to work solely on this. This can be a little tricky for us. So inverse sine of 1/2. Again, we just did this question actually before, so I'm not going to spend too much time, but think through your chart, and hopefully you can quickly have your chart up there. And so you just, draw out your chart. And we quickly see that sine, when is sine 1/2? Oh, that's pi over 6, and that's easy. When is it negative 1/2? Again, remember sine is your first and the fourth quadrant that we base. Fourth gives me the negatives, and first gives me the positives. So the one that I want is going to be negative pi over 6. Easy. However, when is cosine 1/2? Well, that's pi over 3. No problems there. When is it negative 1/2? We can't just negate that. It's not negative pi over 3, and that's where the confusion occurs. It's not just negative, because negative would give us the fourth quadrant. We don't want that. We need the second quadrant angle. And so this would be the first, and the second quadrant would give me the positives and the negatives for cosine. Let's do some more. Sine of x, when is it root 3 over 2? Well, of course, back to our chart here. When is sine equal to root 3 over 2? We quickly look, we got pi over 3. The positive answer shouldn't throw us too much. In the same way, in how we answer this, we could have said, okay, we want to get rid of that sine, and so what I would do is I would do the inverse of both sides and see it as an inverse question, because really it's the same idea. And understanding that when you see inverse, that what it's basically saying is what you see here. Sine of what angle would equal root 3 over 2? The answer would still be the same, pi over 3. How about this one? Let's just look at it in that inverse form. That would mean I would do the inverse cosine to get x by itself, and I would get x equals the inverse cosine of negative 1/2. And so my approach would be, when does cosine equal, let's start with 1/2, which again is pi over 3. But when is it negative? Well, for cosine, we want the second quadrant angle. We want the one that's closest. All right, cosine of x equals 1/3. Is that on our chart or our graph where we can refer to? No, so this is one we can't solve. So the best way is to get x alone, as they want, and we would do the inverse cosine, get x equals the inverse cosine of 1 over 3. And that's as good as we can make that. So that's where I'm going to leave you. And tomorrow we'll practice a lot with the principal branch. I'll probably have you start the class by drawing each of the branches. And I'm going to have you answering questions from this. So be very familiar with your trig chart. Be very familiar with your trig graphs, because the principal branch is quite important as we answer these inverse trig questions.